Good morning, students. Today we'll be talking about the percent equation, talking about several applications to the percent equation, and doing some examples as well in preparation for overall review. So let's take a look at an overview of what we're going to hit today. First, we are going to review the percent equation for percents. Second, after we've done that, we're going to take a look at the percent times the whole equals the part. We'll take a look at markup and discount rates. And then after that, we will do a small overview on interest, being simple interest and compound interest. Simple and compound interest. So we can take a look at a few of these applications we'll get into in just a second. So let's start with the percent equation. The percent equation talks about percent times the whole equals the part. Now, what is a percent? Let's break down what it means to have a percent. Percent literally means per 100. So I can say this is the same thing as per 100. So you can actually rewrite percent, or the percent sign is the same thing as some number over 100. So when you think about what that means, it means if I have something that's 25% off, I'm saying that's really the same thing as 25 per cent, or per 100. I don't know why I put an extra zero on the back of that. Let's take that off. So 25% is really the same thing as 25 per 100. In the same way, if I have 88% of something, you can rewrite this as a fraction, and you can say this is the same thing as 88 per 100. Now, if you want to take something like 88% or 25% and change it into a decimal, what you can do is you can say, well, I know that the number 25, there are three different routes that we can take. Let's go into blue. So I know that 25% is saying that there are 25 per 100. So looking at this, you can say, well, 25 divided by 100 is the same thing as 0.25. So you can divide the fraction out, and that'll work. Another method that you can do is just divide the fraction by, or the number 25% by 100 in your head, and that's the same thing as taking whatever decimal point right here and moving it over 2 points, which will be 0.25 as well. Now this works with numbers that are greater than 100 as well, and you can take a look at the number 88, or let's say 188%. This is the same thing as 188 divided by 100, which if you turn that into a decimal will be 1.88. So as far as the review of decimals is concerned, you can take a look and say, hey, percent is the same thing as some number times 100. And when you insert the percent equation, you can choose to either put in the fraction for the percent, you can put in the decimal, but you cannot put in the percent sign, the percent as something like, such as 88%. Can't do that one. So let's take a look at an example in which we can see how this is applied. So we're going to take a look at 8 is 25% of some number. So let's rewrite our percent equation down here. We know that percent times the whole equals the part. So we can look at this and say, hey, we know what the part is, we know what the percent is, but we don't know what the whole is. So let's begin filling this in and seeing what we have. Now before, if I were to fill this in right off the bat, I would have a little bit of an algebraic problem. Because if we were to start applying and doing the mathematical equation right off the bat, we would realize that the percent times the whole equals a part. We can't just straight compute that, because we say 25% times the whole, which we don't know what the whole is, equals 8. So first off, let's just change this to a decimal right off the bat. So we'll say 25%, which is 0.25, times some number equals 8. So we're going to have to algebraically rearrange this, and so I'm going to say percent times the whole equals a part. And what I'm really trying to find is I'm trying to find the whole. So if I have the whole number here, then I can say, well, let's see what we can do here. So I need to get the whole alone. So the thing that's keeping the whole alone is this percent number right here. So as far as that is concerned, oops, I don't know what happened there. Let me erase this and write over again with a different color. Let's write in yellow. So if I have the equation, let's see, lighter green, let's do a pink. So percent times the whole equals the part. I want to get the whole alone. The thing that's keeping the whole alone is it's being multiplied by a percent. So in order to undo multiplication, I'm going to divide both sides by the percent. So what this will equal is I'll have the whole will equal the part divided by the percent. Now you may, if you'd like to, you could memorize this equation. But it's so much easier just to algebraically deduce it after memorizing the percent times whole equals part. So let's start with that. So we don't know what the whole is, but we know that the part is 8. And we know that the the percent is 0.25. Well, I can change this and say, well, I want to get this number down here to be not a decimal. So I'm going to multiply that by some number in order to do that. So I'm going to multiply that by 4, and I'm going to multiply this by 4. So if you have 8 times 4, that's the same thing as 64. No, 32, sorry. 32, and that's 32 over 1. So you can now say percent times whole equals part. Well, I know that 32 equals 1, and that's the whole. So now you know that the whole of this equation is 32. So I can rewrite this and say 25% times 32 equals 8. And if you were to multiply this out, it would check, and you would be able to ensure to make sure that it works. Now you can use the same exact method when it comes to a story problem. If I have a story problem and I'm trying to figure out what in the world should I put in which spot, drawing a picture and drawing the equation will help you out significantly. So say that I have a situation where I need to calculate the percent. So we can say, let's say there's a math test that we're taking. So we have a math test. Let me pop this down here a little bit more. Oops, let's try this again. So let's say I'm taking a math test, for example, and the math test says, So the math test has 80 questions on this math test. And somebody was able to get 76 of these 80 questions correct. So that's good. That's a pretty good grade. But they want to know what percentage is this for their final grade. Well, you can start by once again writing the equation percent times the whole equals the part. You say, well, I know what the percent is. Nope, I don't know what the percentage, but I know what the whole is. That's 80. And the part is 76. So there's some number multiplied by 80 to equal 76. So now we have to figure out what is that going to be. You just saw the algebraic manipulation that we did up there, and so you can apply the same thing. But when there's a story, if you have a story problem, simply rewrite the equation and fill in what you know and fill in what you don't know. Oh, I'm running off the screen, aren't I? Let's take a look at some more complicated equations related to the percent times the whole equals the part equation. And this will be a calculation of simple interest. Simple interest is essentially if you were to take a loan from somebody, you pay a certain amount of interest over a certain amount of time. And that simple interest equation is calculated where I equals P times R times T. In other words, the interest that you earn, or that someone will earn from borrowing or lending out money, equals the principal times the interest rate as a percent times the amount of time that you borrow the money out. Now this is a very similar type of problem to the percent times the whole equals the part equation. Because if you look at it closely, you'll realize that the interest is a certain part of the amount of money that you owe. This is the whole. The interest rate is a percent. And the only thing that you don't have in that previous equation is the time. So this is a new aspect to our equation. And so the application of it is if you know three pieces of information, such as I know the part, I know the whole, and I know the percent, but I don't know the time, then I can use these three pieces of information to possibly figure out the time. So we can take a look at a story problem if you would like, but really this is a very similar application to the problems that we'd shown above. So I'm going to let you try this on your own, but when you're reading through the problems, write down the equation. So you say interest times the principal. Principal is really just the whole, the total amount of money. And the interest rate will be in the form of a percent, which once again you'll need to change to a decimal or a fraction. So I'll put some number here, or a fraction. And the time, you can understand what time is as you go along. So finally, in addition to the simple interest problem, we also have a compound interest problem. Now this compound interest problem is a little bit more complicated because it uses the interest of itself back onto the problem. So I'm going to say S equals P times 1 plus I to the nth power, where S is the amount that you have in your savings account, amount, and this will be in the form of some amount of money. Principal, once again, is the whole, that is the certain, or I should say, the amount that you start with. So the initial value of the equation. So I'm going to say starting amount in your bank account. You could, once again, that's going to be a dollar amount. And you're going to multiply that by the number 1 plus I. And I corresponds to the interest rate. So interest rate. So in other words, if I have something being compounded by a certain amount per year, and we'll get there in a second, at a 3% interest rate, I'll put in 3% here. Now once again, you can't pop in 3%, you have to do it either as a decimal or as a fraction. And then what happens is after you've put those pieces of information in, the last thing that you have to put in is n, where n corresponds to the number of times that this interest is applied. So in other words, if something is compounded for 3 times a year or 4 times a year, you'll put in the number 4 into the spot for n. So you're mainly going to use this as a plug and chug right now. When you get to upper level algebra and maybe some pre-cal as well, you will be able to solve for unknowns. Say maybe you don't know what n is, but you know what p and I and s are. Then you'll be able to solve for n and do different things like that. But at this point, you're probably not going to have to solve for them. You'll just plug and chug. So you'll read through the story problem, interpret it, and say, oh, they have a certain amount of money in their savings account. They have a certain amount of money starting out, and the interest rate is this, and the number of times it multiplied per year is this. Plug it and chug it and see what you get. And the last application problem that we'll take a look at today is the commission formula. The commission formula, once again, is the same exact thing as a percent times the whole equals a part, or the basic percent formula. This formula is commission. Commission is a percentage of how much income somebody might make, and that will equal a percent or a part of the amount of money. So the commission times the sales will equal the earnings. So what does this mean? It means that if somebody were to sell a car for a certain amount of money, what percentage would they get? So the commission is going to be a percent number. The sales of a car, for example, is going to be the price of the car, which is the price of the whole thing. And this is going to be the amount that the car salesman will earn if they sell this car. So this is going to be an amount, but it's going to be a part. And once again, this is our percent times whole equation. I'm going to put the percent times the whole equals the part. So when we go back to this equation, you can say that this car salesman or this furniture salesman or whatever it is earning a certain percentage of money, and the amount that they earn will be the part. So when we run it down to the multiple different equations, really the 3 main equations that you need to memorize are the basic percent formula, which is percent times the whole equals a part. The simple interest formula, which is calculated with the interest equals the principal, which is the whole amount, times the rate times the time. And the compound interest formula, which is S, which equals savings or some number. So I just put S there to remember. Savings in cash times, once again, the principal times the equation 1 plus I, where I is interest, times a certain number of compounds annually. So a number of compounding annually. With that said, take a look at this information as well as other equations you may find in the textbook, and I hope that the homework assignment and the test go really well. Have a great day.